In this video, we'll look at various methods of wastewater treatment. The purpose of wastewater treatment is to remove hazardous materials, reduce the BOD, the biochemical oxygen demand, and kill microorganisms. Wastewater treatment methods are classified as primary, secondary, or tertiary treatments. Each stage of treatment reduces the level of the pollution and also the BOD, the biochemical oxygen demand. So we'll start by looking at some examples of primary treatment. So filtering out insoluble solid objects, removing floating objects from the surface of the water. Sedimentation uses gravity to remove solids that sink to the bottom of a sedimentation tank. And flocculation uses chemicals that allow suspended particles to join together.
Water. So I'm going to start off with the primary. And here's a very simple diagram. Basically, you take your wastewater in. You're going to have a simple filter here at the beginning to remove any large objects. The water gets into here, and this is called a settling tank because basically any of the rocks or stones or any heavier material that will naturally settle out will sort of go to the bottom, and then they'll have a mechanism here to sort of remove it. The water is then pumped to the next tank, which is what we call a sedimentation tank. So that's basically trying to force some of the floating material that normally won't settle out on its own, forcing it to actually settle out in a process called flocculation. And so what happens there is you add a chemical, and then the little pieces will absorb to it, and then it will become dense and heavy enough to sink down and form a sludge, which then can be removed. The water after that is clearer, and so in order to kill any of the actual bacteria or organic any of the organisms that might cause problems, they'll add chlorine or ozone. And then after that, the choice is to put it on into the rivers or onto secondary treatment. So it would depend, of course, on the biological oxygen demand measurement after this process to see if the water is safe to just put straight back into the river or if more treatment.
Next, we look at secondary treatment. Secondary treatment involves biological treatment called the activated sludge process. Wastewater is mixed with bacteria-laden sludge and oxygen, which allow the bacteria to break down organic matter. The water is passed into a sedimentation tank where the active sludge is collected and removed.
Wastewater from primary treatment, and this time you're sort of focusing on removing the organic materials. So what you're actually doing is you're adding oxygen into an aeration tank. Aerate means to add air, and in here you have lots of bacteria that are going to do aerobic respiration or decomposition. So this aerobic decomposition will start breaking down these larger organic molecules that have been left over, and then those can be settled down again through sedimentation, and that can be processed around either way. So some of the sludge might be taken back to be processed a couple times, and some of this sludge will help replenish some of the bacteria in the aeration tank. And then some of this will still be, of course, organic material, so it could be useful as a fertilizer. Any of the water will go through, again, another kill zone to kill the bacteria that were over here, and that can be, again, depending on the BOD value, sent directly into the rivers or to tertiary treatment. So to summarize that,
next, we look at the tertiary treatment. Heavy metal ions such as Cd2+, Pb2+, and Hg+, can be removed by precipitation as their solubility in water is very low. Here's an example of cadmium 2+ ions being removed with hydrogen sulfide gas. Phosphate ions can be removed by the addition of Ca2+ or Al3+ ions. And here we have the Al3+ ions reacting with the phosphate ion to give you aluminium phosphate AlPO4. Nitrates are highly soluble in water, so cannot be removed by precipitation. Ion exchange is used to remove nitrates from wastewater. So here's an example of ion exchange where the hydroxide ion, the OH negative ion, is exchanged with the NO3 negative, the nitrate ion. Nitrates can also be removed by biological methods. Anaerobic organisms called denitrifying bacteria turn the nitrogen in nitrates into atmospheric nitrogen.